Hello guys, in this tutorial we are going to learn about electric flux. First we should know the meaning of electric flux, where flux means flow or act of flowing. Now if we relate the electric field is called electric flux. Let us understand electric flux from the figure. As you can see here, these are the electric field lines and they are passing through normal to the area. So if we see the definition, electric flux is the rate of flow of electric field line through a given area placed normal to the field at a point is measured of the strength of the electric field. So the number of lines which is passing through that area, these lines are called electric flux. Now let us see the electric flux depend on which quantities and what are the mathematical formulas. So let's talk about the electric field, in which these electric field lines are passing through that area. If the electric field lines or the magnitude of electric field lines are maximum, then the electric flux is definitely maximum. Or on the other hand, if the electric field lines are minimum, the electric flux definitely minimum. So the conclusion is greater the magnitude, these are the magnitude of the electric field lines, and these are the electric flux. So greater the magnitude, greater will be the electric flux. Lesser the electric field, lesser will be the electric flux. Now in the second case, electric field is depend on the area, as we are having a area A1 and area A2. Area A1 is a smaller one, on the other hand area A2 is greater one. So the electric field line which is passing through the area A1 is less. On the other hand, the electric field line which are passing through the area A2, they are greater. So the conclusion is electric flux is directly proportional to the area. Now the third point is angle theta, in which the area is kept normal to the electric field, and the orientation of the area element decide the amount of electric flux. Thus the area element is a vector quantity, as well as it has a magnitude and the direction. So to specify the direction of the planar area, the direction of the area vector is always normal to the plane in outward direction. So here is the area which is perpendicular to the electric field, but this area vector is in the direction of electric field. Alright, so the angle theta is always formed between the area vector and the electric field. Then here the theta is 0 degree, which is formed between electric field and the area vector. So here the maximum flux we can get it. Now another case, here the area is, here this area is kept in parallel to the electric field, but this area vector is perpendicular to the electric field. So the theta is 90 degree between area vector and the electric field vector. So when we substitute this value in, phi is equal to EA cos theta, substituting the value of theta, cos theta 90 is equal to 0. So here the minimum amount, so there is the electric flux is 0 here. Now combining all the above quantities and forming the mathematical formulation, phi is equal to E dot A, phi is equal to EA cos theta. Here we can say also that the flux is the product of magnitude of the electric field and the surface area A. And when we are substituting here the value of flux is maximum when the theta is equal to 0. When we are substituting theta is equal to 0, electric flux is maximum. When we are substituting theta is equal to 90 degree, electric flux is minimum. This equation is for the symmetric plane. but it is not always necessary that we have a surface. Sometimes we have a area of irregular shape that is kept in an electric field. For that, how to calculate the electric field? To calculate the electric flux of the irregular object, all we have to do is to divide the surface into small element and specify its direction of a planar area which is normal to the plane. And now we check the angle between the area vector and the electric field vector of all the elements and add them. Though we get the total electric flux passing through the area of an object, so the electric flux is phi is equal to integration over integration d phi is equal to integration E dot dA. Electric flux is either positive or negative. As you can see here that the angle formed between the area vector and the electric field vector is greater than 90 degree. So in that case the electric flux is negative, which is called as inward flux, that is always negative. And here you can see that electric field and an area vector is forming 90 degree between them. So here electric flux is equal to 0, and in this diagram you can see here that electric field and area vector is forming angle theta which is less than 90 degree. So in that case it form a positive flux. So the outward flux is always, this one is called the outward flux which is always positive, this is called inward flux which is always negative, and forming 90 degree is always 0. Now let's see one question. To calculate the flux of the electric field E through the surface A in each of these three cases as shown here. Here this is the area, and area vector is perpendicular to this electric field, and this is electric field. So the angle between electric field and the area vector is 90 degree. So electric flux is EA. And here you can see here that electric field is parallel to the area. So area vector is perpendicular to the area. This is from 90 degrees. So here electric flux is 0, and here you can see that it is tilted. So this is perpendicular normal, and this is area vector. The angle between electric field and area vector is theta. So here electric flux is EA cos theta. Thank you.